is the loss of the stresses due to the friction. So this is the friction due to the length effect of the tendons that depends upon the length stress in the tendons or the cables, and the coefficient of the friction between the materials, the contact materials, that is the tendons and the the anchorage or the concrete. So between these materials the friction loss may be arises. The curvature effect, this is also which causes the friction, that is during the design of the curvature of the cables. The loss of the due to this effect is estimated over the length of the cables. So in this the whatever the in this case, the in the case of the post tensioning members, the see here in the post tensioning member, the tendons are been it is been housed in the ducts performed in the concrete. The whatever the ducts is either in the straight or it been curved depending upon the design requirements. The consequently the tensioning the curved tendons, the loss of the stresses which is occurs in the post tensioning member due to the friction between the tendons and the surrounding concrete duct. The magnitude of the loss is of the following types. That is, first one is the loss of the stresses due to the curvature effect, which depending upon the tendons form of the alignment, which is generally follows the curved profile along the length of the beam. Second one is the loss of the stresses due to the Hubble effect, which depending upon the local deviation in the alignment of the cables. The Hubble or the wave effect, the Hubble effect is also known as wave effect, is the resultant of the accidental and unavoidable misalignment of the tendons. Since the duct or the sheath cannot be perfectly located to the following predetermined profile throughout the length of the beam, which is being shown in this figure. Okay, in this to this profile it is impossible to place it exactly on the same position. Mm, and so there is a chances of existing the loss of the stresses due to the pre-stress. Okay, so you can see that one end left corner where it has been jagged, so the profile of the tendons it is been curved, and another end it is been anchored. So here the whatever the magnitude of the pre-stressing force, that px is been determined by px is equal to p naught into e to power of minus mu alpha plus k into x, where mu naught is the pre-stressing force at the jacking, and mu is the coefficient of the friction between the ducts and the cable, and alpha is the cumulative angle. So whatever it has been shown in the alpha in the figure, see here in the figure it has been shown in the alpha, no, that is the cumulative angles. Okay, so in the tangent profiles for the if you draw a tangent for the cable, so whatever the angle which it makes, the tangent it has to be drawn to the cable, and tangent is it has to be drawn to the from the another corner where it has been jacked. So what angle it makes, what angle cumulative angle it will makes, that is an alpha. K is the for this equation, K is the friction coefficient of the wave effect, and E you can take it as 2.7185. Okay, so that is about the formula for determining the stresses, pre-stressing forces in the Indian standard codes. The mu value and K value it will recommends. So for the mu value for the 0.55 it has been taken for the steel moving smooth concrete, 0.35 for the steel fixed to the ducts, and 0.25 for the steel fixed to the concrete, and 0.15 to 0.225 for the multi-layer wire rope cables in a spacer plates provided at the lateral separations, and 0.18 to 0.30 for the multi-layer wire rope. Okay, so the for the friction loss can also be avoided by the several methods, such as over tensioning the tendons by the amount of the equal to the maximum friction loss. And another method is the jacking the tendons from the both ends of the beam. Generally this is been adopted when the tendons are very long, and another is when the angles of bendings are very large. In these cases the friction loss can be reduced, it can be reduced. See here, the friction loss can be seen only in the post-tensioning case. In the pre-tensioning case, you can't see it. The third point, you can see that in the post-tensioning you can see, in the pre-tensioning you can't see the friction loss. There will be no loss in the case of the pre-tensioning. So that's what I have explained. The wave effect is known as a Obel effect. See here, this is the wave effect of the tendons. In the post-tensioning case, the friction is generally which is been at the curved toe of the tendons and vertical components of the pre-stressing force, which is been typically you can see the wave effect of the tendons. This I have already explained. This is the values, the mu value and k value wave effect. So while solving the problem, we'll take this values and we'll solve it. Okay. So that's all about the losses of the friction in the loss of the stresses in the due to the friction in the PSC sections.